This video is going to be a run through the laws of indices. So we've done these in class, we've gone through a couple of questions, but there are some specific questions I want to go through as well. These are the main laws of indices that you need to remember, but there's always, for the first two rules, you need to remember that you need to look at the multiplication or division sign, and you need to have the same base. It's very easy for students to make some silly mistakes, especially when they forget to check that it's a multiplication or division between the numbers and if they have the same base. So if you have numbers with the same base or letters with the same base and you have a multiplication between them, then you can add the powers. If it's a division between them and again you have the same base, then you can subtract the powers. So these are the first two rules. For the third rule, if you have some number raised to a power, then you need to multiply the power. So it's the opposite, or it's not the opposite, sorry, it's very different from the first rule. This time you multiply the powers. Some students mistakenly add the powers. And as for this rule, what it says is that you need to multiply the powers in. So basically what you're doing is you're spreading this n to every part of your every algebraic term, or every term inside. It doesn't have to be a letter. So it's going to be a to the power of n, b to the power of n. And similarly, when the numbers are being divided, you spread the powers there with the last one, given that b is not equal to 0. The denominator is not equal to 0. So these rules you need to remember like the back of your hand and use them continuously. So for the first rule, for the rules, I'm just going to solve a couple of these questions and then you can attempt the rest on your own. So express the following in the simplest form without brackets. So you are meant to use all of these rules. So just going to attempt the first one. So in this rule, I have to spread the bracket, the power in. So it's going to be 2 to the power of 3 multiplied by b to the power of, well, I need to multiply these powers, so 4 times 3. So in this case, I'm using this rule and I'm using this rule. So you will have to use a combination of a couple of rules. In this case, it's going to be 8 and then b to the power of 12. You are expected to simplify these, so there are some powers that you typically should remember. One of them is 2 to the power of 3, being 8. And these you can do something similar. I'm gonna attempt part G. You spread the power into each one, so you can do it in tiny steps. I'm just gonna write the power there, and then 4 times 2, which should be 8, over b to the power of, well, 2 times 2, and that should be 4. Then I'm going to simplify this even further, and it's going to be 16, a to the power of 8 over b to the power of 4. I can't simplify this any further. I'm going to attempt this last one. Again, you spread the 3 in, and it's 5 to the power of 3, x to the power of 6, and then y to the power of 9. Notice that I'm not adding the powers, I'm multiplying. And you end up with 125, and then x to the power of 6, and y to the power of, 9. Do attempt the rest of the questions, and you can attempt more from your book. These are mainly questions based on multiplying, spreading the power, multiplying out of the bracket. I do expect you to know the first 3 rules. Another thing we discussed is negative indices. So negative indices is basically you flipping your number. So if I have something like 2 to the power of negative 4, then it's the same as just flipping it, or another fancy way of saying it, the reciprocal, and then your power ends up being positive. Now if you had a 1 over, say, 2 to the power of negative 3, And again, I wanted to remove this negative. I have to reciprocate it. So bring it above, and it's going to be a positive 3. So this is just another way of writing a negative power or just rewriting a fraction. So I'm just going to do a couple of questions. I'm going to do A and B just to compare how different these are. And then I'm going to attempt in P. Do try the rest of the questions, especially those that look very similar, like J and K and N and O, because they have the same terms, but the negative is on a different value. So for part A, all of 3b is being raised to the power of a negative 1, which means I could reciprocate all of it. And that's what you get. But for b, only the b is raised to the power of a negative 1, which means I need to only reciprocate the b. So notice how different this is. I shouldn't reciprocate the 3 because it's not being raised to the power of negative 1. And then similarly would be the same for C and D and the rest here. As for M, all of it is being reciprocated, so it's just simply this. As for P, it's quite an interesting one. The Y is a negative 2, which means I need to remove it and reciprocate the Y. Nothing happens to this xy to the power of 3. I just keep it as it is. I can deal with the Y separately. I'll bring it up and it's going to be y to the power of 2. As soon as I reciprocate it, the power changes. You flip the sign. And in here, I can use a couple of rules. I'll put the power first, so I have x to the power of 3, y to the power of 3, and y to the power of 2. Then I can use another rule while I have a multiplication. I have the same base, hence I need to add the powers this time. So I have y to the power of 5. I'm gonna leave it there and then have a go at the rest of the questions. Each would be interesting to do because you have a power of a negative 1 and you have a negative inside as well. Do have a go at the questions. Shouldn't be impossible to do, but you will be using a combination of different rules. I do want to start seeing how we can simplify expressions and using the rules when you have algebraic terms. So for this one, to simplify algebraic terms, first deal with the coefficients and then deal with the indices. So first you can do 4 times 3, which is a 12, and then you have, again, you use laws of indices. You have a multiplication, you have the same base, so you add the powers, so you end up with p to the power of 8. For this one, you have 12 divided by 4. Deal with the coefficients first. 12 divided by 4 is 3. P to the power 6 divided by p to the power 2. You have division. You have the same base, so you subtract the powers, and so you end up with p to the power of 4. Another way of seeing this is to say, well, 12 to the power of p to the power 6, 4, p to the power of 2. These simplify to 3. And then the 6 minus 2 becomes a 4, so you have 3p to the power of 4. As for this one, again, remember to spread the brackets in, so you have 5 to the power of 2, and then a to the power of 3 times 2, which is 25a to the power of 6. And that's it. Is very similar to what we've done before. I just wanted to run through more specific examples. A few longer ones now. For all of these, do pause the video and attempt some of these questions. You can simplify the numerator and then deal with the denominator, or you can deal with the denominator. It's up to you, however you're comfortable with this. I'm going to simplify the numerator first. So I'm going to do a 3 times 6, so that's 18. And then I have a multiplication. I have the same base, which means I need to add the powers, so that's a to the power of 10 divided by 9, a to the power of 6. And then I can divide the values. Obviously, I could have simplified here. And so I'll end up with 2 for the coefficients, and then 10 minus 6, that would be 4. So a to the power of 4. As for this one, again, using the same method, you can get the same answer. I'm going to use a quicker method here just to show you how this could be simplified. Because I'm multiplying and dividing, there's no plus and minus, which means I could deal with this in any order I want. So I'm going to simplify the 4. This is going to end up being 1. This is going to end up being 2. And then I can simplify this 2 again. 2 goes into 2 once, and 2 goes into 6 3 times. So the coefficients will be 3. And then with the powers, well, I have 6 minus 2, which is 4, and then it's going to be 4 plus 4, which is 8. So I'm going to have a to the power of 8. And we can check it using the method we did above. If I simplify the numerator first, 4 times 6 will give me 24. And then the a power will be a to the power of 10. And the bottom will be 8, and then a to the power of 2. And then 24 divided by 8 will be 3, and the a will simplify to a to the power of 8. Now these are a few more challenging ones. You can attempt these. These are a bit more advanced. I don't expect you to attempt them in current exam conditions. Maybe in the future, you never know, but you can do them. They're not impossible to do. A couple of things to remember. Anything to the power of 0 is 1, so this y to the power of 0 is actually 1. And you'll have to deal with powers of a half as well, which are interesting. So anything to the power of a half is actually a root. And if I give you y 3 over 2, that's actually me saying, well, that's y cubed and then a square root. That's the root part, that's the cube part. Or you could say square root and then cube. So these are, we haven't covered these root 3 over 2 or 1 over 2, but you can still use the facts that you have. You can still try to simplify these if you want to. And this is all I'm going to cover on laws of indices. This should be useful when you're dealing with standard form and when we're doing surds as well.